Next, we have the law of cosines. And the law of cosines is nice in that we don't have any ambiguous case, so that's a good thing. We've already talked about solving oblique triangles with the side-side angle situation or angle-side angle or angle-angle side. Well, what if you only have the measure of one angle, or if you don't have the measure of any of the angles? Then you can use the law of cosines. So here's the law of cosines. C squared equals A squared plus B squared minus 2AB cosine C. Now, notice how this is organized. You've got C squared equals, and your angle is C. So that's always the case. Whether it's B or A, always what you're finding or what it's set equal to is the side opposite the angle that you're going to use for cosine there. And then it's just the other two sides that make up the rest of it. The squared plus squared minus 2 times those two sides. So looking at an example, we've got a side angle side situation here. The first thing that we can do is we can find the measure of side A. So A squared would be B squared plus C squared minus 2 times B times C times the cosine of angle A. And then you just do some math. So we've got 49 plus 64, which is 113. 2 times 7 times 8, that's 112. Minus cosine of 120. That's 169. So that's C squared, not C. So to find, A squared, not A. So to find A, we just need to take the square root of 169. It's 13. So that side is 13. Now that we've got that side, we can use the law of sines to find another angle. So we've got sine of 120. We've got the measure of angle A and its opposite side, so we can plug into the law of sines. And let's find angle B. So sine of angle B over side B, which is 7. Cross multiply. And then divide by 13, so B will be the inverse sine of 7 sine 120 divided by 13. And that is 28 degrees. Now we've got the measure of two of the angles. You can use law of sine to find the other angle, but you don't need to because they all add to be 180. So add 120 and 28, subtract that from 180, and we get 32 degrees. And so this triangle is solved. Let's look at a situation where we have a side-side-side triangle. Now, in this case, we don't have any of the angles. So you can actually just pick whichever angle you want to start with. I'm going to start by finding angle B. So that means I need B squared equals A squared plus C squared minus 2 times A times C times the cosine of B. And so you see we're going to be looking at some inverse cosine here in a minute. So we've got 100 equals, that's 8 squared plus 5 squared is 89. 2 times 8 times 5 is 80. So we need to subtract 89 from both sides. That's 11 equals negative 80 cosine of B. I'm going to move this because I don't have quite enough space right there. There we go. And then divide by negative 80. So B will be the inverse cosine of negative 11 over 80, which is 98 degrees. Okay? So now that we've got the measure of an angle, we can use law of sines going from there. You could use the law of cosines again if you wanted to. Most people just find sines easier. And let's find angle A. So sine of A over 8. So cross multiply, divide. A will be the inverse sine of 8 times the sine of 98 degrees over 10, which is 52 degrees. Now all we have to do is find the measure of angle C, and we'll be done. So add 98 and 52, subtract from 180, and angle C measure is 30 degrees. So that's how you use law of cosines in both cases. Example 3, let's look at an application. It says 2 airplanes leave an airport at the same time and on different runways. One flies directly north at 400 miles per hour. The other airplane flies on a bearing of north 75 degrees east at 350 miles per hour. How far apart will the airplanes be after 2 hours? Well, we don't have a picture. Okay, so let's draw it. So we've got airplane A. It says one flies north at I think my picture that I've got on my paper is a little bit off. Okay, so basically we've got the airport right here, and flying due north is one of our airplanes. And that airplane flies for 2 hours at 400 miles per hour. So how far away is it? 2 times 400. So this distance is 800 miles. The other airplane flies at a bearing of north 75 east. So it's 75 degrees east, so of north, so like right here. And it's going at 350 miles per hour for those 2 hours. So it's traveled 700 miles after 2 hours. And what we're trying to find is the distance between these 2 points. How far will they be apart? And we're going to call that B. I'm going to call this point B, A, and C. Doesn't really matter. And so we've got a side angle side situation. We can use the law of cosines. So B squared will be A squared plus B or C squared minus 2 times A times C times the cosine of 75. We'll have to take this to the next page. We don't really need the picture at this point. Okay, so let's see what we get. 700 squared plus 800 squared is 1130000. So 1,130,000. And then 2 times 700 times 800 is 1,120,000. And cosine of 75 degrees. So just put that in your calculator. And, well, what I didn't even find that yet. I just said that B would be the square root of all this stuff. And I put that in my calculator. So I found 917 miles. These two airplanes, after 2 hours, will be 917 miles apart. The last idea for this section is Heron's, or Heron, I don't know how to say that, formula. But it's another way to find the area of a triangle. What if you've only got the measures of the sides? Okay, that other area you had to have an angle. What if you've just got the sides? So if you've just got the sides, then you first find S. S is your sides added up and divided by 2. After you find S, you plug that in to there, and there. And you have S times S minus A, side A, times S minus side B, times S minus side C, and square root all that. It's not as bad as it looks. So we've got a triangle with sides 6, 16, and 18. So we'll start by finding S. It's half of 6 plus 16 plus 18. That's 20. And then our area then will be times 20 minus side A times 20 minus side B times 20 minus side C, and the square root of all that. So it'll be the square root of 20 times 4, or 14, times 4 times 12, which is the square root of 2,247 square meters is the area of this triangle. And that's the end of this section.